The last concept we're going to look at in Chapter 3 is how to solve exponential or logarithmic equations. By exponential equations, I mean ones that have variables for exponents in it somewhere, and by logarithmic equations, I mean an equation that somewhere has a log written out. So when you're solving an exponential equation, the first thing you should try to do is write both sides of the equation using powers of the same base. So see if you can write both sides as 2 to a power, for example. Once you've done that, you can cancel out the bases, set the exponents equal to each other, and then solve the equation. If you can't write both sides of the equation with the same base, then you need to isolate whatever has the exponent on it on one side of the equation, and then take the log of both sides. And I'll demonstrate that on a couple examples. Once you've taken the log of both sides, you can use the properties of logarithms to bring the power out front, and then solve for that, solve for the exponent. So on this first example for the math lab assignment, you'll see that we have an exponential term here because it has a variable in the exponent spot, but there's also something outside of the exponential term. So to isolate the exponential term, you're going to divide both sides of the equation by 18 in this case. And try to leave your answers in a fraction form so that it's easier to see common bases on the two sides of the equation. So right here, hopefully you would recognize that if you took 1/3 and squared it, that would equal 1/9. So it is possible to get a common base on this one, because now we have 1/3 raised to a power on both sides. So once you get a common base, whenever that's possible, now you can just set the exponents equal to each other. So you essentially get to ignore the base, and then you can finish solving the equation normally. So the opposite operation for dividing by 5 would be multiplying by 5. And that should be it for your answers. Now here's an example where you can't write both sides using a common base. And a good hint for that will be that you have ugly decimals like this, because I'm not going to expect you to recognize something like 1.02 to the 2/3 power to get the other side. So if you have ugly decimals in there, it's probably going to be one where you have to take log of both sides of the equation. So if I'm performing a log operation on both sides, then I'll have log of 1.02 to the x power equals log of 4.2. Now the reason we do this is because one of our log properties that we learned earlier lets us take the exponent and bring it out front to multiply instead. This allows us to finish solving the equation because now I have x times log of 1.02, which means if I divide both sides by that number and then plug this into the calculator, I'll be able to get an answer. Do know that the directions specifically ask you to round your answer to 4 decimal places, so keep that in mind while you're plugging that in. So using my calculator on this one, I got the answer 72.4694. I'm not going to actually work all the way through this problem, but I did want to give you a hint that if you see an e anywhere in the equation somewhere, then instead of using the log base 10, the common log, you'll be better off using the natural log, the ln one, because then when you're simplifying the expression, there's a rule that says ln of e is equal to 1. So you can use that as a shortcut. If you take the natural log of both sides and then get an ln of e anywhere in it, you can replace it with 1 for simplifying purposes. Other than that, it works pretty much the same as the one I showed on the last example. So now we're going to look at the other type of equation you might have, an equation that already has a logarithm in it. If this happens, you're going to want to isolate the logarithm on one side of the equation first, so get rid of anything outside of it using opposite operations. Then rewrite the logarithm in exponential form. That's a process we went over a few sections ago as far as what is the base of the exponent compared to the base of the logarithm, where does the power go, etc. So you might want to look back over that if you've forgotten how to change from one form to the other. And then you should be able to perform more solving operations to get the variable by itself. So here's an example of a logarithmic equation. I call it that because it has a log in it. To change this back into the exponential form, the base of the logarithm, which in this case is 6, gets raised to the power on the other side of the equation. And then what goes on the other side of the equation here is whatever you were taking log of. So that whole expression, 4x minus 3 in this case. If there had been anything out front being multiplied by the logarithm, we would have needed to get rid of that first. That's what I meant when I said isolate the log. But since this one just has the log of an expression in here, there was nothing to move to the other side of the equation first. Well, now that I have 6 to the first power equals 4x minus 3, I'm just going to try to get x by itself. So the opposite operation for subtracting 3 would be adding 3. And then the opposite of multiplying by 4 is dividing by 4. Now notice they ask you to type an integer or a decimal. So instead of typing this as the fraction 9 over 4, it sounds like they want us to use 2.25 instead. So here's an example of a more complicated logarithmic equation that has some other parts to it that are outside of the logarithm that I need to move over. So the opposite of adding 3 is subtracting 3. Usually you want to do your adding and subtracting steps before you do your multiplying dividing ones. It's kind of like the opposite of PEMDAS, order of operations. And then since I have 7 times the logarithm, you're going to divide both sides by 7. So here at this point, you have to remember that the natural log is a logarithm with base e. So if I'm changing this into the exponential form, you just have to know that this is going to be e to a power and set it equal to x minus 7 in this case. This is not going to be a number you can evaluate without a calculator. So again, just perform your opposite operations. In this case, add 7 to both sides. And then your calculator should have an E key on it. So make sure you're just using that, and then with parentheses, set it to the 1/7 power. Don't just hit raised to the 1 divided by 7, or it's only going to raise to the first power. So make sure you use parentheses around the exponent, and then add 7 to your answer in your calculator. So rounding my answer to 4 decimal places, what I'm getting is 8.1536. And that should be all for the notes. Thank you for y'all's time.